Okay, solving problems using equations. So exercise 6E from the text. This is the exercise where you start to use all your algebraic tools that you've been collecting to solve real world problems, or Mathland problems for our case, but you could use algebra to solve real problems. Okay, so it's a very important exercise, and we're going to be doing this for the rest of your maths career at school. And you start with your year 8 skills and then you build them up, and each year you'll have more sophisticated problems that you can use algebra to solve. So let's get started. So it says in the textbook, when forming an equation to solve a problem, use the following steps. Step A, identify the unknown quantity and clearly define a pronumeral to represent it, including units if necessary. So step A is basically read the question. What do you want to know? The thing you want to know is usually the thing that you need to assign the pronumeral to. Part B, express any other unknown quantities in terms of this pronumeral. There won't always be another unknown quantity, but when there is, sometimes there's some sort of mathematical link that you can express that second quantity in terms of the pronumeral you defined in part A. Part C, form the equation by carefully considering the worded questions and ensuring that the expressions on both sides represent the same quantity. So looking at the question, reading the question, extracting the information to somehow link all together into an equation. Part D, solve this equation. Okay, use all the skills you've done through all the previous exercises to find out the value of the pronumeral. And then part E, this is an important part, and a part that actually unfortunately often gets skipped because people get so excited they've found the pronumeral, they forget that they need to actually answer the question. Okay, the pronumeral is something you invented. You actually have to now relate that back to the question and make a conclusion. Reread the question, see what they want to know, and make sure you've answered that in words. Okay, let's do a couple of worked exercises from the text. This one here says a rectangle is 3 times as long as it is wide. If the perimeter is 176 centimetres, what are the dimensions of the rectangle? So a clever thing to do here to make sure you've got your head around things is to draw a diagram. So I've just drawn a simple rectangle here, and we could assign some pronumerals to that diagram. So it says a rectangle is 3 times as long as it is wide. So it makes sense to make the width x, and if the width is x, 3 times as long as it is wide, the length must be 3x. Okay, so we've sort of introduced our pronumerals in a diagram, but we should also officially introduce them in words. So we'll say let the width be x, and look at our units, what we've got, centimetres, so x centimetres. So we've introduced our pronumeral, hey, meet x, he's going to be our width. Then we look and think, oh, is there anything else that we can link? And yes, we've got the length, so therefore the length is 3x centimetres. All right, so we've got some good information here. Now we've got to see if we can make an equation. It says, if the perimeter is 176 centimetres, what are the dimensions? So we've got the dimensions in terms of x, we can link them together as the perimeter and solve that equation. So we've got perimeter, add all the distances around, and so we've got x plus 3x plus x plus 3x is equal to 176. And then we've got a equation that we just need to solve. So we've got x plus 3x plus x plus 3x is 8x, and that's equal to 176, and divide both sides by 8, we've got x is equal to 2 and 1 and 2 again. So x is equal to 22. Now x isn't what they asked for, they asked for the dimensions, so we've got to relate that to the dimensions. And we defined x was the width, so we can conclude, therefore the width is 22 units of centimetres, and the length is 3 times that, so 3 times 22 is 66 centimetres. Okay, so we've answered the question. It said, what are the dimensions? Here are our dimensions, and that's the end of that question. Let's move on to the next one. Okay, this next one's a classic. They always have these sort of tricky questions. And it says, Rob is presently 20 years older than his son, Bob. They also often tend to make the names very confusing. In 12 years' time, Rob will be twice as old as Bob. Find their current ages. Okay, so the goal at the end of all this is to work out how old they are now. But we've got information linking them now, and we've also got information linking them in 12 years' time. Okay, so we'll start with making one of them the pronumeral. So we'll go let X be, and which one are we going to go for, Rob or Bob? I think it makes sense to make Bob the pronumeral, because then when we say Rob compared to Bob, it's going to be adding 20, which is better than if we did it the other way around. If we made Rob the pronumeral, we'd have to take 20 away, and then we've got negatives involved. So try to work smarter, not harder. Pick your pronumeral so that you're going to have nice numbers to play with. Okay, so we've got their current ages, and then in the question it says in 12 years' time. So before we start linking their ages together in 12 years' time, let's think about in 12 years' time what each of their ages are compared to where they are now. So in 12 years' time, Bob is he started at X now. In 12 years' time, he will be X plus 12. Rob is currently X plus 20. In 12 years' time, he'll be X plus 20 plus 12. Let's write that down. And that X plus 20 plus 12 simplifies down to being X plus 32 years. So if we've got their ages in 12 years, we've got their ages in current time, we now need to work out how this all links together. And the key is in that second sentence. It says, in 12 years' time, Rob will be twice as old as Bob. So we need to be looking at this second bit here of their ages in 12 years' time and link them together. And it says, Rob will be twice as old as Bob. So Rob's age, which is X plus 32, is going to be twice Bob's age at 12 years' time, which is twice X plus 12. And that's our formula that we're going to have to solve. So now we just go through and use the process that you've been doing all this chapter. Okay, so we've got X plus 32 equals, expand those brackets, we've got 2X plus 24. All right, we've got X's on both sides. So first of all, we want to get the X's onto one side, and because of the size of them, we're going to go for the right-hand side. So we'll take X away from both sides. So we've got 32 equals, so 2X take away X is just X plus 24. We're nearly there, and so we've just got to take 24 from both sides, and we'll write it in the other order. So therefore, X is equal to 32 take away 24, which is 8. Okay, so we haven't quite finished. We've found our pronumeral, but we need to link it back to the question. So X we define to be Bob's current age. That's part of it. We've also got to get Rob's current age. So let's make a conclusion. Therefore, Bob is X, so 8 years old. And Rob is 8 plus 20 is 28 years old. Okay, and that's it. So every single time, same process, read the questions, probably should be step before A, read the question carefully. Next, assign a pronumeral to your unknown. Next, if there's another thing that you can relate in that same pronumeral, you need to find that relationship. Then find an equation, solve your equation, and do a conclusion. Same steps every time. Okay, I'm going to put over on the materials section, I'm going to put write up a couple of the tricky challenge exercises, exercise questions. So have a look over there, because they are very interesting ones, but if I did them now on the screencast, it will take you the whole lesson. So I'll write them up ready for you, and you can go have a look if you're interested. I'll also be on Zoom, so if you need any help, drop in and I'll give you a hand. Okay, bye.